Hello, today we are going to look at the drainage basin system, which is a subtopic under hydrology and fluvial geomorphology in the AS A level geography. Our objective for today is we should be able to identify and explain the relationship between the output of a drainage basin. Secondly, we should be able to explain the relationship between the stores in the drainage basin and the relationship between the flows in the drainage basin. To begin with, we'll talk about the hydrological cycle. The hydrological cycle is powered by solar energy and gravity. It's a closed system because new water doesn't get created. Let me explain by saying that neither does water come from space into our atmosphere, nor does water leave our atmosphere. It is this same amount of water which has been in the world for millions of years. This means that there is a fixed amount of water in our system and that this amount does not change. Most of the water is stored within the world's ocean, which is 97%, with another 2% stored in ice caps and glaciers. The remaining 1% is fresh water in rivers, lakes, and the ground and the atmosphere. People use fresh water, and fresh water accounts for less than 1% of all the water on the planet. This is why we need to fully understand the hydrological cycle in order to use the available fresh water as efficiently as possible. As the diagram depicts, the sun heats water from the ocean, lakes, rivers, and the earth's surface. This water is then evaporated into the atmosphere by the sun. Evaporation is when water changes from water to water vapor. Additional water is also drawn from the soil by plants and is then evaporated into the atmosphere from leaves and stems through the process known as transpiration. Transpiration is the evaporation of water through the stomata in the leaves of plants. As the air rises, the temperature drops. This moisture-laden air condenses, forming clouds and eventually resulting in precipitation, which can be in the form of rain, hail, or snow. Some of this precipitation fall onto the mountains, in the sea, others into rivers, lakes, and the rest onto the land. The water found on the surface of the earth makes its way back to the ocean through rivers, and this process of transfer is known as surface runoff or overland flow. However, some of the water is then intercepted by vegetation, which means that the plants store them and use them for other purposes. Those that are not intercepted by any vegetation falls directly onto the land, and this process is known as true fall. Some of this rain seeps downwards into the soil through the process known as infiltration. This infiltrated water can find its way to the river, lake, or sea through the process of transfer known as true flow. True flow is the downhill movement of water horizontally beneath the land surface through the soil. It occurs in the layer above the bedrock. But before I continue, let's take note of the difference between true flow and true fall. Students usually interchange them. True flow has to do with the horizontal movement of water beneath the surface of the earth. And true fall is when water is not, the precipitation is not intercepted by any vegetation and it falls directly onto the land. So let's do well to take note of that. Sometimes we do interchange them or mistakenly define them for each other. Okay, let's go on. If the bedrock below the soil is permeable, then the water percolates the rock and is stored as groundwater. Percolation is the vertical or downward movement of water through the soil and or the bedrock. This water flows down through the rocks until it reaches the level of saturation or water table. The level of saturation here means a zone where all the spaces are filled with water and can no longer take any more water again. Most of the groundwater eventually flows down through the rock towards the nearest river. We call this base flow or groundwater flow, and it's normally a very slow process indeed. Now on this same slide, I want to ask a question. Why is it a closed system? Why is the hydrological cycle a closed system? You can pause the video, answer, write it down, and later we'll look at the answers together. It's a closed system because there's definite amount of water in the system, and that is, this amount does not change. Water does not leave our atmosphere, neither do we receive water from space as well. This is what makes it a closed system. On this slide, let's revise what we learned in the previous slide. You can flow with me. The process where water changes from a liquid to water vapor is known as evaporation. Now let's go to the next slide. Next question. The process by which cooling vapor turns into liquid is known as condensation. So go to the next question. Water that falls on the earth's surface, example rain, snow or hail, is known as what? Precipitation. The movement of water over the land, possibly as a river, is known as surface runoff. Plants giving off vapor from their leaves is known as transpiration. The last one, water that has sunk in through the soil into the rocks below is known as, where is my mouse? Groundwater. Well done, great work done. Now let's go to the next part. I want you to pause the video, match all these words with their various definitions, and now after that the answer will be shown to you. So I have just 2 seconds. I'm going to show the answer. Okay, let's solve it. This is the solution, so you can cross check and find out if you had all correct. If you didn't get correct, don't worry, go over it and I'm sure you get them correct. Now there's a sample past question which I want us to talk about. This question was taken from 2016 May-June paper 1-3. Question 1. Using the diagram below, name input A. This is the input A, so you name what it is. The flow B, which is here beneath the water table. The store C here, and output D. So you can pause the video, answer them, and the answers will be shown rightly in the next 2 seconds. Okay, so these are the answers. These are the answers. We have precipitation for A, transpiration for D, surface storage for C, and groundwater flow for B. Now that we are done with hydrological cycle, I want us to discuss the drainage basin. So one may ask, what's a drainage basin? A drainage basin is an area of land drained by a river and a tributary. The drainage basin is part of the hydrological cycle, and it's an open system, unlike the hydrological cycle. It's an open system because water flows into, through, and out of the drainage basin. We have to understand the drainage basin in order to be able to understand how rivers behave, especially if we want to explain the changes in river discharge and river flooding. This is the part of the hydrological cycle that operates once rain has fallen into the drainage basin. It is known as a drainage basin system because it has inputs, stores, flows, and outputs, which we are going to discuss in the next slide into more details. With the diagram on the left side of the slide, let's label the part of the drainage basin. We have the source, which is an area where the river begins. We have the tributary, is a river which joins a larger river. Then we have the mouth, which is where the river flows into the sea or sometimes a lake. We have the confluence, the point at which two rivers join. I want to explain this point more. Sometimes students do get them wrong by affiliating confluence with tributary. Please, confluence is the point where the two rivers meet, and a tributary is when the river is the river that is joining another river or a larger river. So please take note of that. Confluence is the point at which two rivers meet, and the tributary is a river which joins a larger river. Thank you very much. Now we have watershed or interflow. That is the boundary dividing one drainage basin from another. Now, geographers in different parts of the world often use different words for the same thing. In our situation, the UK, drainage basin is a phrase used to describe the area drained by a river and its tributaries. Some UK geographers also use the phrase river catchment. This phrase is also used in the USA as the watershed. The confusion arises here because in the UK, the word watershed is used for the boundary of a drainage basin, not the drainage basin itself. It is probably best to avoid the word watershed and stick to drainage basin and interflow. Thank you. On this slide, let's revise what we learned in the previous slide. Let's pause the video and match the correct definition with the correct word. So pause the video. I have 2 seconds. So this is the solution. This is a solution, so you can check again and make sure you have them correctly answered. If you didn't get correct, don't be worried at all. Go back, revise, and I know you get it correct the next time. Another task is ahead of us again. Let's pause the video once again and then answer the following questions. The solution will be shown as soon as possible. We have 2 seconds. Thank you. So these are the solutions, so we can go through it and confirm them. The drainage basin system has only one input, which is precipitation, but has 2 outputs, which is evapotranspiration and river discharge or channel flow. Evapotranspiration is a combination of evaporation and transpiration. Let's take note of that. This helps us to understand the ways in which rivers operate. For instance, if we have 2 basins with identical input of precipitation, but the first basin has much more evapotranspiration than the second basin, the first basin will have much less water in the main river than the second basin. This simple fact has huge implications for the way that rivers behave in different climatic zones and from seasons to season. It also shows flows of water from one place to another in the drainage basin. And examples of these flows are surface runoff or overland flow, infiltration, percolation, through flow, groundwater flow, and groundwater flow. However, it's only 3 of these flows that provide water to the river. They are the overland flow, through flow, and base flow, which is also known as groundwater flow. These flows operate at different speeds. The balance of the flow in any one drainage basin will determine how quickly a river responds to an input of rainfall. A basin with a high proportion of water reaching the river overland through overland flow will tend to have flash floods. However, a basin where most of the water reaches the river via base flow may never experience any serious flooding. Now let's go to the stores. It also shows stores, and these stores helps store water in the drainage basin for some time. Example of these laws include interception by vegetation, soil moisture, sand, surface storage. Sorry, interception, groundwater, soil moisture, and surface storage. Areas with little or no vegetation tend to have high level of overland flow because the rate of infiltration is usually exceeded because the land itself becomes easily saturated. On this slide, we are going to take each component one by one and explain them. So I'll start with precipitation, which we all know is the only input in the drainage basin system. It is the rain, snow, and hail falling from the sky. However, rain is the most important form of the precipitation. Now from there we move to interception. This is rain which is stopped before it reaches the surface of the ground. It is usually intercepted by vegetation, especially by the leaves of trees. For instance, during a short summer shower, it is possible to stay dry by standing under a tree because the tree leaves intercept and store the raindrops before they reach the ground. The next of the flows is the stem flow. In a prolonged rainstorm, the leaves become saturated and water will begin to drip to the ground. Stem flow is another important way in which water moves from the tree to the ground, simply flowing down the outside of the tree trunk. The next one has to do with the transpiration. Plants draw water from the soil through their roots and allow it to evaporate to the air through their leaves. The water vapor exits the leaves through the stomata pores, which are found on the underside of the leaf, and we call this process transpiration. Now, let's go to the surface storage. During a prolonged or heavy rainfall, the infiltration capacity is usually exceeded and water starts to build up on the surface. This buildup is what we call surface storage, and it usually produces puddles. Now the next component of the drainage basin is the infiltration, and it usually occurs when the first rain reaches the ground and it usually soaks into the soil. So this process is what we term as what infiltration. The speed at which it can do this depends on the nature of the surface and its permeability. For instance, in urban areas which has a lot of concrete surfaces, water doesn't seep into the soil, which means that there's little infiltration, leading to high overland flow, which eventually leads to a lot of flooding in urban areas. Now, the next one has to do with percolation. But before I start with the percolation, I want us to understand one thing here. Infiltration is when water seeps into the soil. Percolation is the downward movement of water through the soil and or the bedrock. Now, sometimes students get these definitions wrong, especially with percolation and true flow. True flow is the horizontal movement of water through the soil and not vertical movement of water. So let's take note of that. So as I said, percolation the physical movement of water through the soil and or the bedrock. Now let's go to the groundwater and base flow. Water that percolates into the bedrock is known as groundwater. This water flows down through the rock until it reaches the level of saturation or water table. Most groundwater eventually flows down through the rocks towards the nearest river. We call this base flow or groundwater flow, and it is normally a very slow process indeed. The water table moves up and down depending on the amount of rainfall percolating downwards and the amount of base flow flowing out of the rocks into the rivers. Where the water table reaches a surface other than the riverbed, groundwater reappears as what? Springs. Where the rock structure is favorable, groundwater can remain in the rock for a very long time, and a typical example is in the Sahara, where there are underground stores of groundwater aquifers which fell as rain thousands of years ago. Groundwater is an important source of fresh water. Wells can be dug, boreholes can be drilled down to the water table, and the groundwater can be extracted. Because it can be extracted, and it's pure because it has been filtered through rocks, and it's one of the purest water that one can get. However, continuous operation of the hydrological cycle however, if people unsustainably take all these water from the water table, there will be a time that this water will eventually get finished because the rate at which it's discharged is not as the way at which the rate of abstraction is taking place. Okay, now let's go to the next one. Overland flow. On a slope, this surface water will flow downhill towards the river, producing overland flow or surface runoff. Overland flow is a relatively quick process when the soil is saturated and the rain continues to fall. The rainfall will then produce surface runoff. This runoff is called saturated overland flow. As I said earlier, urban surfaces such as concrete are designed to be flat and impermeable. They rapidly produce Hortonian overland flow, which is shallow, laminar, and fast moving. Hortonian overland flow is most commonly encountered on city roads, construction sites, and dirt roads in the countryside. This process poses a significant problem to steep, recently plowed rural areas where we have enough rainfall. The next one on this slide is the true flow. True flow is the movement of water horizontally beneath the land surface through the soil. As I said earlier, let's take note of the true flow and the percolation. Water penetrates through the soil surface and is drawn downwards by gravity and continues to flow until it reaches an underground river or lake. Water can move through the soil by a form of piping. And the last but not the least is evapotranspiration, which has a combination of evaporation and transpiration. Together, we refer to this water loss from the basin as evapotranspiration. It's an important output of water from the basin, and in an equatorial rainforest area, it can amount to 80% of the total output of water from the basin. The last of the components that we're going to discuss today is the channel flow. Now, let's talk about the last component of the drainage basin, which is the channel flow. Precipitation, which is usually rainfall, reaches the river via overland, through reflow, and base flow. These are the three main ways in which rainfall reaches the river, which we discussed earlier, which is overland flow, through flow, and base flow. Once it is in the river. It flows downhill towards the sea as river discharge. This is another output of the drainage basin. On this slide, let's look at this class activity. It's on WordWall. You can copy the link which will be provided below the video. Copy, go there, and this will be the interface. This is also you match the location of each drainage basin system to its location. You can pause the video and the answers will be shown in the next 2 seconds. Okay, that's okay. So these are the answers which we've done. I would advise that we get used to the definitions for and the locations for all these, because they usually bring them. So our advice, we get used to that. Thank you. Now there are sample past questions which are collated. So these, you can go through them. One thing I noticed is that the questions keep repeating themselves, or they are in the same pattern: define, briefly describe, others. So I advise that we take our time to go through them one by one, try to define them, try to answer them, and see how best we can fit. If you're unable to do it, you can go take the past question and go and get the answers from the mark scheme as well. Thank you. This ends our lesson for today, and I believe we now know the relationship. We can identify and explain the relationship between flows, between stores, between the output of the drainage basin. Now, my references were from bbc.uk, Geography for Cambridge International AS A-Level by David Kelly, Mauro Fruto, and John Nansen. And I got some of the pictures from Google as well. I acknowledge every detail that I added. Thank you.